So today we are going to do a question. So the question is, find the expression of centripetal force that depends on mass m, radius r, and speed v of the body. So here in a question we are given the factors that centripetal force depends on, but in real life you won't have those. You have to find those, you have to guess. So it will be much more easier doing it by this way, where you are given. So we have given you the factors that are the factors of centripetal force, because it helps us to derive the equation without having to think a lot. So this is just for practice. So let's try the question. So let us derive the centripetal force. The centripetal force. So from the question, or according to the question, we know that centripetal force, which I'm going to represent by capital F. So centripetal force bracket big F depends on mass, radius, and speed. So now let's write the dimension of the following that we found. So the dimension of mass m is m, the dimension of radius, which is a length, so the dimension will be L, and finally the dimension of speed. The dimension of speed will be distance over time, so length over time, so it will be L t minus 1, same as that of velocity. And finally the dimension of centripetal force will be the same as of that of force, so you can find it using the formula mF equals to ma, or you might know it as well. So now we found the dimension of each individual component. So now since we know that the centripetal force depends on mass, we don't know to what power, so let's say this is A, and this will be equation 1. Similarly, F is directly proportional to r to the power b, this will be our equation 2. And finally F directly proportional to v to the power c, which will be equation 3, where a, b, and c are constant to be found or to be determined. So they are constant to be found. So now so let's combine all these three. So combining equation, it's not good, let's not write equation. Combining 1, 2, and 3, we will get F is directly proportional m to power a, r to the power b, and v to the power c. So to remove this proportionality constant, to remove this proportionality sign, let's add a proportionality constant, so which will be k. It can be anything, but I'm writing k to make it easier for me. So m to the power a, r to the power b, v to the power c, and this will be our equation 4. So here in this equation, k is dimensionless proportionality constant. So it's a dimensionless proportionality constant. The proportionality constant may not be dimensionless, it may have a dimension, but for this example, when we are deriving various physical quantities, a relation between various physical quantities, we consider that the k or proportionality constant is dimensionless, because it makes our life a heck of a lot easier. So now to find it dimensionally, we can, since we think that the equation is dimensionally correct, or that we know that it is dimensionally correct, which means both the dimensions should be equal. So let's write the dimension of centripetal force, which will be mlt minus 2. Here k is dimensionless, so no need to write. The dimension of m is m to the power a. The dimension of r is of length, so l to the power b. And the dimension of v, the speed, is lt minus 1 to the power c. So now let's write it down. So here, let's say m, there is only m, so it will be m to the power a. Let's see l, there are two l, which will be b plus c, and here in t it is raised to the power of minus c, because minus 1 times c will be minus c. And we write b plus c because it follows the law of indices. So now equating power of same base on both sides. So let's go back. Now let's see for m. Here a is equals to 1, so a is equals to 1. Let's call this equation number 5. And here b plus c also equals to 1 when we see in L. So b plus c equals to 1. Let's call this equation number 6. And finally c is equal to minus 2. So we can write minus c is equals to minus 2. So from these equations alone, we can say that a is equals to 1 and c is equals to 2, which means keeping 2 over here, we will get b is equals to minus 1. So now we have the constants that we need to find. So now we can write, so then equation 4 becomes, and equation 4 is the equation that we were talking about, which is this. It will be k m to the power a, which is 1, and r to the power b, which will be minus 1, and v to the power c, which will be 2. As you can see here, a is 1, b is minus 1, and c is 2. So writing this a little bit formally, we will get k mb square by r, which is our equation 8. So this is the equation or the relation we were trying to find. This is the expression we were trying to find. So therefore equation 8 is the required expression. So we can't actually find the value of k, which the proportionality constant, by dimensional analysis, sadly. So but actually the value of k in this case is 1, which was found experimentally. So by this way we can find the relations between various physical quantities using dimensional analysis. In the next video we are going to talk about another question about this topic as well.